Hello students, welcome to CDS Quest YouTube channel. Let's begin with the class. Now let's do an example on previous class concept. The example is like this. Here AD is parallel to EF is parallel to BC. These three lines are parallel to each other, and the angle BCF, no so sorry, BCA, this angle is equals to 50 degrees they are giving, and EFD, this angle is 120, and EBC, this angle is 90 degrees. This information is given in the question and asking for this Z angle, Y angle and X angle. Okay, these values they are asking. Now if you see, this is in the form of Z, as this is two parallel lines and a transverse line is passing through these two parallel lines. So here it is forming Z shape. So this angle, this 50 degrees, this angle is equals to this angle. What we call this? Alternate angles. Alternate angles. When Z or N type of angles is formed, that angles we call alternate angles. Yes or no? So this Z is also equals to 50 degrees. This Z is also equals to 50 degrees. So Z value we found. Here answer solution, Z angle is equals to 50 degrees. And if you see here, these are two parallel lines and a transverse line is passing through these two parallel lines. So now as I said, two parallel lines and a transverse line is passing through it. Now this angle is equals to this angle. This interior angle is equals to this angle. They are corresponding angles. So here this is a parallel line and this is a parallel line. So this x is equals to this exterior angle, this z. X degrees is equals to this z degrees. So this x is also equal to 50 degrees according to corresponding angles. Okay. So the x is also equals to 50 degrees. X is equals to 50 degrees. Okay. Now here, I will drop this. Here this complete angle, this straight angle is 180 degrees. As we know, straight angle always forms 180 degrees. This complete angle is 180 degrees. Now this top angle is 120 degrees. So the remaining angle, this angle is 180 minus 120 degrees. Yes or no? 180 minus 120. That is equals to 60 degrees. That is equals to 60 degrees. So this angle EFC is equals to 60 degrees. Now listen carefully. These both are parallel lines and a transverse line is passing through them. Now this angle is equals to this angle. They are also corresponding angles. Corresponding angles. This is the interior angle. This is the exterior angle. These both angles are equal. Now apply this concept here. Here this is the parallel line and here is one another parallel line and transverse line is passing like this. Okay, this is the parallel line. This is the transverse line. Sorry, transverse line. This is the transverse line. Now this angle, this y is equals to this EFC angle. Okay, so that is 60 degrees. As we know, this is 60 degrees. So y also equal to 60 degrees. Y also equal to 60 degrees. So write that one here. Y is equals to 60 degrees. Okay, understood with this problem? This is the way of solving this type of questions. Okay, okay. I think you people are confused with corresponding angles, alternate angles, and vertically opposite angles. I will tell a small trick to remember. Here, two parallel lines, and this is a transverse line. And if you see here, according to the alternate angles, this Z is forming here. This angle is equals to this angle. Yes or no? So I said when Z type of figure is formed or N type of figure is formed or reverse N or reverse Z, this type of angles is formed, then this angle is equals to this angle is equals to this angle is equals to this, and this angle is equal to this. This I have said in previous class. Now if you see here, this is making A. Yes or no? Yes or no? This looks like A. A means alternate angle. Remember like this. This is the small trick. Here also it is, look at up to this half angle, half place, half diagram. Here also making A. Here also making A. So A means alternate angle. Remember this title. You have to remember this heading alternate angles. Okay. Sometimes this is also asking the examination. Okay. Okay. Here A like symbol is forming. So when this A like symbol is forming, that is alternate angles. That is alternate angles. Remember this. Okay. This is a small trick. Here A like it is forming symbol. So this is alternate angles. And with corresponding angles also we have a trick. Suppose these are two parallel lines and this is the transverse line. Now this angle is equals to this angle. This one, corresponding angles means. So here it is making like C, touching this angle and this angle, it is making C. C means corresponding angles. Okay, okay. You have to remember like this. Corresponding angles in the sense not only this. Here this exterior is equal to this interior and this exterior is equals to this interior angle. These both also equal. Okay, okay. Suppose this interior is equals to this exterior. These both also corresponding angles. They are also both equal. And this interior also equals to this exterior. These both also corresponding angles. They are also equal. Remember this. Okay. Okay. At the time of at the place of corresponding, so alternate angles also this angle is equal to this I have said, and this angle here also it is forming z now, like this angle is equal to this angle, and this angle here also forming z, like, just wait, I will show. Here also it is making like z, not exact z, but it is in the form of z. So this angle is equal to this angle. They both are also alternate angles. Okay, okay, okay. Okay, this is about alternate angles and corresponding angles and vertically opposite angles. We have done with this. Now let's begin with the triangles. Triangles. First of all, we need to understand the condition for formation of triangle. The condition is, suppose this is a line segment of 10 centimeters. 10 centimeters. Now another line segment of, suppose it is of length 3 centimeters. 3 centimeters. And another line of length 4 centimeters. Now if you lift upwards or downwards these both lines, they won't touch each other, they won't meet each other. These two lines, this 4 centimeters line and this 3 centimeters line won't touch, does not touch each other. Yes or no? Because they are of less length. If you drop this to the line AB, suppose this is line AB, if you drop them to the line AB, they touch this 3 centimeters line touch here and 4 centimeters line touch here, and remaining this remaining 4 plus 3 7, 7 plus here 3 centimeters gap is there. So these two lines there is no possibility of touching, meeting each other at top side or bottom side. There is no chance of meeting each other. So here there is no chance of forming a closed figure, formation of a closed figure. There is no chance. Here some gap is there, so there is no formation of a closed figure. Closed figure is not forming here. So here, when suppose this length is, I consider it as C. Suppose this length I consider it as A, and this length I consider it as B. Now C A plus B is less than C. Yes or no? A plus B, if you add 4 plus 3, that is equal to 7. So 7 is less than 10, no? C is 10. So at this condition, no closed figure is forming. That means no shape is formed. Yes or no? Yes or no? There is no shape formed here. Suppose let's take the same line of 10 centimeters. This is the same line AB of 10 centimeters, and I have taken, suppose this is the midpoint, 5 centimeters, 5 centimeters, midpoint. Okay, up to A to this point is 5 centimeters, and this point to B is also 5 centimeters. Okay, this is the midpoint of AB. Now I am taking 5 centimeters line, 5 centimeters line. This is also 5 centimeters, and this is also 5 centimeters, 5 centimeters. If you drop them, onto the line AB, these both lines will meet each other when they coincide with this line AB. there is no chance of meeting of these two lines, 5 centimeters, 5 centimeters line. There is no chance of meeting top side or bottom side of line AB. They meet only if they come and fall on the line AB. When they meet only when they coincide with the line AB. Okay. If I drop this line onto the AB line, so it is up to here, it will come. And this line also, this 5 centimeters line also come up to here, and they meet each other here. But no shape will form. No shape will form. They coincide each other. Okay. They coincide with the line AB. They will meet, but they coincide with the line AB. No shape will form here also. So here, this is line C. I assume this is A and this is B. Now A plus B is equals to C. They are coinciding, completely coinciding with this line. Here also no shape will form, but they are coinciding with the line AB. So they are called collinear. Collinear lines. Okay, okay, just wait. Suppose I am taking the same length of line again. Just wait, guys. Okay, suppose I am taking the same length of line of AB of 10 centimeters. This is the line AB of 10 centimeters. Now, suppose I am taking a line of length about 7 centimeters. For example, 7 centimeters this is. And I am taking another line of length 5 centimeters. 5 centimeters. Now, there is a chance of meeting these lines because why? Because 10 centimeters, this 7 plus 5, they both are greater than 10. Sir, no. 7 and 5, the sum of these two centimeters. Suppose 7 plus 5 greater than 10, no? This is 12 greater than 10. 10. So 12 is greater than 10. So in the case of the lengths of the two lines is greater than the third side, then the closed figure is forming. The closed figure is forming. So this is the condition of formation of triangle. Triangle will form either upwards or downwards if you draw the lines greater than the third side. The sum of these two lines is greater than the third side, then the triangle is going to form. Just wait. Here, suppose this length, consider it as C. This length I consider it as B, sorry, A, and this length I consider it as B. So A plus B greater than C. Yes or no? This is 12, this is 10. So 12 is greater than C. At this condition, the there is a chance of meeting of these two lines so that the closed figure is forming. That closed figure of three sides is called triangle. Triangle. Here triangle is formed. Now you understood the formation condition for formation of a triangle. Let's write in the statements that condition for, write this point, condition for formation of triangle. Triangle. The condition is sum of any two sides of a triangle must be greater than the third side. Okay. The condition is, suppose this is a triangle. Here it is A, its length is A, its length is B, and this side length is C. Now the condition is A plus B must be greater than C. Then also forms triangle, or B plus C must be greater than A, or C plus A must be greater than B. Sum of any two sides of a triangle must be greater than the third side. Okay, then there is a chance of forming a closed figure of three sides, that is we call triangle. Okay, okay, this is the condition. You have to remember this. You have to remember this. The questions will be asked from this condition also. From this condition also, already once asked in the serious exam. Okay, okay. This is the condition for formation of triangle. Sum of any two sides of a triangle must be greater than the third side. Okay, okay. And you have to remember this also, when A plus B greater than C, no shape will form. A plus B is equals to C, then collinear lines will be formed. The lines will collinear to each other, and that means coincide to each other. And when AB is greater than C, then triangle will form. Triangle will form. Okay, okay. Next, this is the condition for triangle. You have to remember. Now, always I am saying sum of interior angles of a triangle is equals to 180 degrees. Yes or no? Suppose this is a triangle. This is the triangle, and it's labeled as A, B, and C. Now this angle, sum this angle A plus angle B plus angle C, I'm saying that is equals to 180 degrees. How? I will just prove it with a small trick. That is, suppose this is a line, this is a line parallel to BC, parallel to this BC line, okay, and touching the vertex A. I am drawing this line touching the vertex A and parallel to BC line, this line, okay. Now if you see, suppose I am considering this angle is alpha, this angle is alpha. As we know, as we know, this is one parallel line, this is one parallel line, and a transverse line is passing through these two parallel lines. And now here Z is forming. Z is forming. Z means alternate angles are forming here. Alternate angles are forming here. So this angle is equals to this angle B. So this is also alpha. This is also alpha. Yes or no? Yes or no? Now this is one parallel line and this is the another parallel line and a transverse line passing through them, and this angle is equals to this angle. This also forming Z here. This is also forming Z here, like this Z. So this angle is equals to this angle. Yes or no? Yes or no? They are also alternate angles. So suppose this angle I am considering as gamma, and this angle also gamma, gamma. This angle C also gamma. Now this is this line, this angle I am taking it as beta, beta. Now alpha plus beta plus gamma is equals to, here if you see, this straight angle is equals to 180 degrees. Yes or no? Straight angle, I am said in the first class, that is straight angle is equals to 180 degrees. When I said type of angles, this is, I said straight angle. This is a straight line. Straight line always form 180 degrees. So 180 degrees, this is a straight line. Straight angle means alpha plus beta plus gamma. This three, sum of these three makes this complete straight angle. So straight angle, as we know already, alpha plus beta plus gamma. Alpha plus beta plus gamma is equals to 180 degrees. 180 degrees. Okay. 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 Now this inside angle, this angle is beta. So beta is there here. This angle B is alpha. So alpha is there here. This angle C is gamma. So gamma is there. So sum of interior angles of a triangle alpha plus beta plus gamma is equal to 180 degrees. Yes or no? Hence proved. Hence proved with the statement. So you have to write the statement that sum of interior angles of a triangle is equals to 180 degrees. You have to write this statement in your notebook. Okay. Sum of interior angles of a triangle is equals to 180 degrees. 180 degrees. Okay. Next. Next, let's go with the types of triangles. Types of triangles. Triangles are majorly classified into two types, majorly classified into two types based on angles, and the second one is based on sides. On these two bases, the triangles are classified. Okay, first let's do with the angles. Angles based on angles. If the space is enough for you in the notebook, write like this only. Write the heading types of triangles and draw like this a chart, and here only you have to write what the statements or what the conditions I write. Okay, okay. At the place of angles and at the place of angles you have to write the given information which I have given. Okay, okay. So it will be easy for you and easy for understanding whenever you open the book for revision. Okay, okay. Based on angles, first of all, the first one is acute angle triangle. Acute angle triangle. Acute angle triangle means, suppose this is a triangle, all the angles must be less than 90 degrees. This angles are less than 90 degrees. This angle also must be less than 90 degrees. This angle also must be less than 90 degrees. These three angles must be less than 90 degrees. Write the condition. All three interior angles must be less than 90 degrees. Less than 90 degrees. So that type of triangle we call acute angle triangle. Acute angle triangle. The triangle which is less than 90 degrees. The angles of the triangle, the three angles of a triangle less than 90 degrees, then that type of triangle we call acute angle triangle. Okay, okay. This is the first classification. Second one is right angle triangle. Right angle triangle. Suppose this is the triangle. In this triangle, at least one angle, not at least one angle, only one angle must be equals to 90 degrees. 90 degrees. Then that type of triangle we call right angle triangle. That means in the triangle, in a triangle, one angle is equals to 90 degrees. One angle must be equals to 90 degrees. So that type of triangle we call right angled triangle. Right angle triangle. Okay. Next. Third one is obtuse angle triangle. Obtuse angle triangle means in a triangle one angle must be greater than 90 degrees. This angle must be greater than 90 degrees. Greater than 90 degrees. Okay. Write down the statement. The statement is in a triangle any one angle must be greater than 90 degrees. Okay, must be greater than 90 degrees. So that type of triangle we call obtuse angle triangle. Okay, okay. Next, next. These are the three types based on angles. Based on angles. This is based on angles we have done, and next based on sides is there. Based on sides we are doing now. Okay, based on angles is one is acute angle triangle, second one is right angle triangle, and third one is obtuse angle triangle. Now based on sides, based on sides, the first one is equilateral triangle. Equilateral triangle. Equilateral triangle must have all sides of equal length. That means suppose this length A, suppose this length is A, this length is B, and this length is C. This A length, B length, C length, A is equals to B is equals to C. These three lengths must be equal. So this type of triangle we call equilateral triangle. Equilateral triangle. Write down the statement. The statement is the lengths of all three sides are equal. The lengths of all three sides are equal. Then it is called equilateral triangle. Okay, okay. And okay, just wait guys. Okay, no problem. And in this equilateral triangle, you have to remember these points. In equilateral triangle, suppose this is the equilateral triangle, all angles must be equal and they are equal to 60 degrees. All angles must be equal to 60 degrees. In equilateral triangle, all angles equals to 60 degrees. All angles are equal angles. All three angles is equal to 60 degrees. You have to remember this point. Okay. And In equilateral triangle, only acute angle triangle will form. Okay, okay. Remember these points. First point is the length of all three sides are equal. That is equilateral triangle, that we call equilateral triangle, and all three angles is equals to 60 degrees. Okay, all three sides, all three angles, interior angles is equals to 60 degrees. Remember this point. Okay, okay. Next, let's go with the second type based on sides. Second one is isosceles triangle. Isosceles triangle. In this type of triangle, two sides must be equal. Any two sides. That means, suppose this is the triangle. This length and this length must be equal. Any two lengths. So, if this length and this length is equal, then this angle will be equals to this angle. If this is theta, this one also theta. You have to remember. If this length is A, then this side length also A. This type of triangle we call isosceles triangle. Write down the statement. The length of any two sides are equal. This is the definition of isosceles triangle. The length of any two sides are equal. That type of triangle we call isosceles triangle. This length and this side length are equal, and that means A equals to A. Now, isosceles triangle forms it forms acute angle triangle. Also, it forms right angle triangle. Also, it forms obtuse angle triangle. That means this is acute angle triangle. This theta and this angle will be less than 90 degrees only. So this is acute angle triangle, and this length are equal. So that's why this is isosceles acute angle triangle. If I draw this triangle, here it is 90 degrees. So if I say this length and this length is equal, then this triangle also isosceles triangle. These two lengths are equal. So any two sides are equal, then that triangle we call isosceles triangle. So this also isosceles right angle triangle. Here right angle is there, 90 degrees is there, one angle is 90 degrees. So this is right angles 90 degree, right angle isosceles triangle. So three types of triangles can be formed with isosceles triangle. Okay, you have to remember this. Next, third point. Sorry, not third point. Third type of triangle is scalene triangle. scale and triangle. In scale and triangle, all sides are of different length. Write the statement. The length of all three sides are different. Okay, this is the condition. This length is different from this length. This length is different from this length. Okay, all three sides are of different length in scale and triangle. So this type of triangle is called scale and triangle. So here also it forms acute angle triangle, right angle triangle, and obtuse angle triangle. These three type of triangles also will be formed. If this is closed figure, here it is less than 90 degrees, less than 90 degrees, less than 90. So this is acute angle, scale and triangle. If I draw like this, this is the right angle triangle and this is the hypotenuse. And this length is different, this length is different, this length is different. So this is right angle, scale and triangle. If I draw like this triangle, this length is different, this length, this length, this length, these three lengths are different, and this is one angle is greater than 120 90 degrees. So this is obtuse angle triangle, obtuse angle, scale and triangle. So three types of triangles can be formed with scale and triangle. Okay, you have to remember this. Now now let's do few examples so that you will get a clear picture of types of triangles. Once I will revise it so that these type of examples you can do easily. Okay, first triangles are classified into majorly classified into two types. One is based on angles and based on sides. And based on angles, first one is acute, the second one is right, and third one is obtuse. And based on sides is equilateral, and based on side second one is isosceles, and third one is scalar. Okay, here acute angle means less than less than 90 degrees, all angles less than 90 degrees. Right angle means one angle must be equals to 90 degrees, and acute angle triangle means greater than 90 degrees. At least one angle, any one angle must be greater than 90 degrees. And equilateral triangle means all sides must be equal, all three sides of equal lengths. This is the triangle. Suppose this length, this length, this length, these three lengths must be equal. Then that type of triangle is called equilateral triangle. And isosceles triangles means any two sides must be equal. Any two sides will be equal. So that type of triangle we call isosceles triangle. And scalar triangle means all three sides are of different length. Okay, all three sides are of different length. And here in equilateral triangle, all three angles are 60 degrees. All three angles are 60 degrees. And in scalar triangle, In scale and triangle, just wait. In scale and triangle, this length is equal to this length, suppose, then this angle must be equals to this angle. Okay, two angles will be equal in isosceles triangle. Isosceles triangle, two angles and two sides will be equal. Remember this. And equilateral triangle, three sides are equal and three angles are equal. If you write this statement in your notebook like this also, if you want, in equilateral triangle, three angles are equal and three sides are equal. And isosceles triangle, two angles are equal and two sides are equal. And in scale and triangle, three angles are different and three sides are different. Okay, 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 okay. Now I think you are understood with this. Now let's go with the examples so that you will get the clear picture. Now 45 degrees, 60 degrees, 75 degrees and 50 degrees, 50 degrees, 50 degrees and 80 degrees and 60 degrees, 60 degrees, 60 degrees, 30 degrees, 60 degrees, 90 degrees, 45 degrees, 45 degrees and 90 degrees. Now by seeing this angle you have to say what type of triangle it is based on angles, based on sides. As we know, based on angles, three type of triangles: acute, obtuse, right, and based on sides, three types: equilateral, scale, and isosceles. Okay. Now, from first here, if you see these three angles, these three are less than 90 degrees. Sorry, this is greater than symbol. Less than 90 degrees. Less than 90 degrees. So these three angles less than 90 degrees. So it is acute angle triangle. Yes or no? Yes or no? Acute angle triangle is all three angles must be less than 90 degrees. So no angle is more than 90 degrees or equal to 90 degrees. So this is acute angle triangle. Acute angle triangle. And if you see, all angles are of different. No angle is different. In isosceles triangle, I said two sides, two angles are equal. And in equilateral triangle, all three angles are equal and 60 degrees, 60 degrees, 60 degrees, I said. But in scale and triangle, no three angles are equal. All are different angles. So here 45 degrees, 60 degrees, 75 degrees. All are different angles. So this is scale and triangle. In scale and triangle, all angles are different. This is scale and triangle. Now if you see here, these angles. Now I said one example. You just stop the video for few minutes and try to identify the which type of triangle it is. Okay. Now here 50 degrees, 50 degrees and 80 degrees. If you see here, all angles are less than 90 degrees. So it is acute. acute. According to angles, it is acute angle triangle. And according to sides, these two angles are same, 50 degrees, 50 degrees. So 50 degrees, 50 degrees, when these two angles are same, when there is a two sides will be equal, then two angles are equal. So it is at the time of isosceles triangle. At the time of isosceles triangle only this condition will come. Two angles will be equal. So this is isosceles triangle. Now here if you see 60 degrees, 60 degrees, 60 degrees. Three angles are less than 90 degrees. So it is acute. Based on angles, it is acute angle triangle. Based on sides, it is 60 degrees, 60 degrees, 60 degrees. Three angles are equal and equal to 60 degrees when the triangle is equilateral triangle. So equilateral triangle. It is equilateral triangle. Now 30 degrees, 60 degrees, 90 degrees. One angle is equals to 90 degrees here. So when one angle is equals to 90 degrees, when the triangle is right angle triangle, then one angle will be equal to 90 degrees. So this is right angle triangle. Okay. Okay. And the three angles are different. So this is scalene. Three angles are different. So it is scalene. Now the last one is one angle is equal to 90 degrees. So it is also right angle triangle and two angles are same. Two angles are same in isosceles triangle. Two angles, two sides will be same in only isosceles triangle. So it is isosceles triangle. Isosceles triangle. Okay. I will do some more examples so that you will get a clear understanding. Suppose 20 degrees, 40 degrees and 120 degrees and 35 degrees, 35 degrees, 110 degrees. Okay, these are the two. Now according to angles and sides, okay. If you see one angle is greater than 90 degrees here, greater than 90 degrees. When one angle is greater than 90 degrees, then that type of triangle we call obtuse angle triangle. Yes or no? In previous slide only I said obtuse angle triangle, and based on sides three angles are different, so it is scalene. Here if you see this angle is greater than 90 degrees, so one angle is greater than 90 degrees, so it is called obtuse angle triangle. This angle also, this triangle also obtuse angle triangle. And two angles are equal here, 35 degrees, 35 degrees. When two angles are equal, then two sides are equal. That means two sides are equal. So this type of triangle we call isosceles triangle. Isosceles triangle. This is the way when angles are given, you need to identify which type of triangle based on angles, based on sides. Okay, this is the way of understanding, identifying the type of triangles. Okay. Okay, next, if the angles are given, this is the way of identifying the type of triangle. Now I will give the sides length. This is angles I have given here. Now if I give the sides, suppose 30 centimeters, 20 centimeters and 50 centimeters, I will give the side length like this. Then you need to identify the which type of triangle it is. You have to understand. You have to identify. Now for this we need to have few formulas. They are for the acute angle triangle, for right angle triangle, for obtuse angle triangle. For these three, I will say it once only. So the formula for this is acute angle triangle is no end of this table. Okay. For this, a square plus b square greater than c square. And for right angle, a square plus b square is equals to c square. For obtuse angle triangle, a square plus b square less than c square. Okay. A, B, C are the length of the sides. Lengths of the sides. Suppose this is a triangle. This is A, this is B, this is C. This is C. So these are the lengths of the triangle. A, B, C are the lengths of the sides of the triangles. And you need to understand this. You have to write this. A comma B are the two smaller lengths, and C is the bigger length, big length of three sides. This A comma B are the two smaller lengths of the three sides, and C is the big length of the three sides. Okay, you need to understand this. You have to write this also. These are the conditions. These are the formulas. Just wait. This is the for acute angle triangle. This is the for right angle triangle. This is for obtuse angle triangle. And AB are smaller lengths and C is bigger, and AB are smaller and C is bigger, and AB are smaller lengths and C is the bigger length. Okay, you have to remember this. You have to remember this. These two statements will be applicable to these two formulas also. Okay, let's do examples. Let's do the examples based on this. Now 6 centimeters, 7 centimeters and 9 centimeters. You need to identify the which type of triangle it is based on angles, based on sides. Based on sides it is very easy. Why? Because already sides are given here. These three sides are different sides. So directly we can understand that three sides are different when scale and triangle. In scale and triangle, all three sides are different. All three sides are different. So this is scale and triangle. And based on angles we need to find. Now This is the smaller length, this is the smaller length, this is the bigger length of the three sides. So this is considered as C. I already said bigger length is C and remaining smaller lengths are considered to be A, B. Now the formula is A square plus B square. We have to see the either it is equal to C square or greater than C square or less than C square. Okay. 6 square is 36 and 7 square is 49 and 9 square is 81. Okay. Sum of this is 85. 85 and 81. Which is bigger? 85 is bigger. So A plus B greater than, sorry, A square plus B square is greater than C square. This is just 9 square, no? 9 square, 7 square, 6 square. Okay. So this condition is when acute angle triangle, as we seen, A square plus B square greater than C square, then it is acute angle triangle. Then that is acute angle triangle. So this is acute angle triangle. ACUTE, acute angle triangle. This is the way of identifying the type of triangle when sides are given. Okay. Let's do one more. 5, 5, 6. Based on angles, sides. As we know, based on sides, two sides are equal. When two sides are equal, the type of triangle is isosceles triangle. Two sides are equal, isosceles triangle. Directly we know this condition for isosceles triangle. Now based on angles we have to find now. Now 5 square is 25 plus 25 and 6 square is 36. 25 is 50. 50 is greater than 36. So A square plus B square is greater than C square. This condition also acute angle triangle condition. So it is a acute angle isosceles triangle. This sides is given now, that this sides will, with these sides the triangle will form acute angle isosceles triangle. Okay, acute angle isosceles triangle will form with this sides. Okay, let's do one more. Suppose 6, 6, 6. Three sides are given. Now you need to find out according to angles and sides. As we know directly, three sides are equal. So it is equilateral triangle. Based on sides, it is equilateral triangle. And based on angles, we need to understand. Already I said equilateral triangle always form acute angle triangle. Always equilateral triangle forms acute angle triangle. If you don't know this, then do this. 6 6 are 36, 6 6 are 36 and 6 6 are 36. This is 72, 72 greater than 36. So this is condition A square plus B square greater than C square. This is acute angle triangle condition. Yes or no? Yes or no? So this is the acute angle equilateral triangle. Okay. Next sides 3 comma 4 comma 5. I have given this. You need to say based on angles, and based on sides. Angles, sides. These three sides are different, but so these three sides are different. So it is scale and triangle. scale and triangle. Why? Because three sides are different, so it is called scale and triangle. Now, according to angles, we have to 3 square is 9, 4 square is 16, 5 square is 25. So this is 25. 16 plus 9 is 25. 25 is equals to 25. So a square plus b square is equals to c square. This condition at the time of right angle triangle. So this with these sides right angle triangle, scale and triangle will form. Okay, with these sides right angle triangle, scale and triangle will form. Right angle, scale and triangle will form. You need to identify like this. Okay, I will give one more. You need to answer for this. I won't say here. In the comment section, you have to post your answer. These are the sides according to angles, according to sides. You have to say the what type of triangle it is. Okay, okay. This is your homework. Next. Now I said sum of interior angles of a triangle is equals to 180 degrees. Now suppose this is a triangle, this is one exterior angle, this is another exterior angle, and this is another exterior angle. Now sum of these three exterior angles of a triangle, any triangle will be equals to 360 degrees. 360 degrees. For better understanding, I will take a equilateral triangle. Equilateral triangle always forms 60 degrees inside. 60 degrees inside. 60 degrees inside. Now this is straight line. Straight line. Straight line will always form 180 degrees. 180 degrees. So inside 60 degrees is over. So outside we left with 180 degrees minus 60 degrees. 60 degrees. Yes or no? Yes or no? That means 120 degrees we left with here outside. The exterior angle is 120 degrees. Similarly, here also 120 degrees. Similarly, here also 120 degrees. Now add these three 120 exterior angles. So 120 plus 120 plus 120 is equals to 360 degrees. Okay, 12 3 the 36. 360 degrees. 360 degrees. So this is not only applicable for equilateral triangle, it is applicable to all type of triangles. Just for better understanding, I used this equilateral triangle. Okay, okay. So write the statement, important statement. Okay, write the statement. Sum of exterior angles of a triangle is equals to 360 degrees. This statement you have to write in your notebook. Okay, okay. Next, Suppose this is a triangle and I extended this side like this. Now this is the exterior angle, this is one interior angle, this is one interior angle. Now the statement is, this is also important statement, sum of two interior angles of a triangle is equals to its opposite exterior angle. This statement you have to write. That means the statement is saying that this is one interior angle, this is one interior angle. Suppose this is alpha, this is beta, and this exterior angle is gamma. So they are saying alpha plus beta is equals to gamma. Alpha plus beta is equals to gamma. If you doesn't see the red color, I will make it into white color. Okay, okay, okay. This is the same. Sum of two interior angles. This is one interior angle. This is one interior angle of a triangle is equals to its opposite. This is the opposite side. Opposite exterior angle. Sum of two interior angles is equals to its opposite exterior angle. Suppose this is a triangle and this is the exterior angle. What is its opposite interior angles? These are the opposite interior angles. Okay, these are the opposite. These two angles is equals to this exterior angle. Suppose this is the triangle and this is the exterior angle. Then these are the two interior angles and opposite angle is this. So these two angles is equals to this third exterior angle. Okay, okay. You need to understand this and write down the statement. Okay, next. Now you have to write the area formulas and perimeter formulas of different type of triangles. Okay, triangle scale and triangle. Suppose this is the scale and triangle of three different sides. Three different sides. Suppose this is A, this is B, and this is C. Then area of this triangle, area is equals to square root of S into S minus A, S minus B, and S minus C. This is the important formula when three sides are of different length. You need to apply this formula. Okay, and S is equals to semi perimeter. S is equals to A plus B plus C divided by 2. This is the semi perimeter form S formula. First you need to find the S, then find the area. Okay, okay. And perimeter of this triangle is equals to A plus B plus C. Okay, this is the formula for perimeter. Three formulas for scale and triangle. Perimeter means nothing but summation of three sides. This border length is called perimeter. This border length is, this side length is A, this side length is B, this side length is C. So this border length, this complete border length is called perimeter. That's it. Okay. The border length is called perimeter. So border length is A, B, C. So A plus B plus C is the perimeter. Next type of triangle is equilateral triangle. Suppose this is A, this is also A, this is also A. Three sides are equal. Then area formula is area is equals to root 3 by 4 A square. This is the formula for equilateral triangle. Area of equilateral triangle formula. And the perimeter, as I said, perimeter is equals to the boundary length. A plus A plus A, that is 3A. A plus A plus A is 3A. 3A is the perimeter. Okay. Next, suppose this is the height H and base length is B. Now the area for this type of triangle is area is equals to half into base into height. Half into base into height. This formula we have studied from our childhood. So this is the formula for this type of triangle. When height and base is given, so half into base into height, this formula you have to apply. When right angle triangle is given, sorry, right angle triangle. So this is the right angle here. Suppose this height is H and this base length is B. Now the formula for this type of triangle also, area is equals to half into base into height, and the perimeter is equals to the boundary length. Boundary is HB and this hypotenuse length. Hypotenuse already we know. Suppose this base plus height plus square root of the hypotenuse formula is H square plus B square. This is the formula for right angle triangle. Okay. Okay. Next type of triangle is isosceles triangle. Isosceles triangle is two sides are equal. This is, suppose this is A and this is A and this is B. Now area is equals to B by 4 square root of 4A square minus B square, and perimeter is equals to 2A plus B. This is the formula for area and perimeter. Okay, these two sides are equal. Okay, okay. Next type of triangle, here they are given the triangle and one angle and the sides. When a triangle is given and two sides are given, in between the given sides that angle is given. Here suppose this two sides are given and this theta is given, then only this formula is applicable. Suppose these two lengths are given and this angle is given, then this formula will not applicable. And this theta value is given also, then this formula is not applicable. Suppose this theta value is given and this side length and this side length is given, then this formula is applicable when theta must be between the given side lengths. Okay, this is the condition. This is the condition. Theta must be between the given side lengths. Okay, the angle must be between given side lengths. So the formula for this is area is equals to half into AB sine theta. This is the formula for this question. Okay, okay, okay. Let's do an example. After that, we will wind up the session. Okay, the question is like this: the side AC of a triangle ABC is produced to D such that this is equal to CD. If angle ACD is equal to 70 degrees, then what is the angle? Okay, the triangle is given like this. Suppose there is a triangle like this. This is A, B, C, and this side length is extended. This side length AC is produced to D, up to D, and he is saying that this CD length is equals to BC length. This both lengths are equal, and now join BD. Okay, now here it is forming BCA. BCA is a isosceles triangle. Two sides are equal, no? Two sides are equal. This side is equals to this side. So it is isosceles triangle. And I said in isosceles triangle, two sides equal and two angles also equal. What are that angles? These angles are equal. Yes or no? Yes or no? Now they are giving this C 70 degrees and asking for this Y value and X value. Y value and X value. Now, as we know, this complete angle, this straight angle is 180 degrees. Yes or no? Now, this half angle is 170 degrees. So, this angle is 180 minus 70 degrees only, no? 180 degrees minus 70 degrees only, no? So, that is 110 degrees. 110 degrees. So, in triangle BCD, this triangle BCD, in this triangle angle, suppose this angle, sorry, I have rubbed this is X, this angle is Z, this angle is Z. Now angle x, angle y, angle z must be equals to 180 degrees. As we know, the condition of triangle must have all sum of three angles will be equal to 180 degrees. Sum of three interior angles must be equal to 180 degrees. From BCD triangle, angle x, angle z, angle y equal to 180 degrees. I have written like this. Okay. Now as we know, this is the isosceles triangle. Isosceles triangle have two equal sides and equal angles. What are the equal angles? X is equals to y. This angle is equals to this angle. This both angles are equal. This angle equals to this angle. Okay. Okay. X is equals to y. Now here in the place of y I will put x because x is equals to y. They both are equal now. So at the place of y I will substitute x. So angle x plus angle x plus this angle z is equals to 110. We have found here. So 110 is equals to 180 degrees. Now 2 angle x plus angle x is equal to 2 angle x plus angle x is equals to, send this 110 to another side. So 180 minus 110. So 2 angle x is equals to 180 minus 110 is 70 degrees. So 70 degrees, and angle x is equals to 35 degrees. 2 ones are 2 35s. Okay. Okay. If you know one angle, so if you know x is equals to y, so this angle is equals to 35 degrees, and this angle, this y is also 35 degrees. 35 degrees. This is the way of solving the problem. Okay. This is the example. Okay. Okay. That's all for today.